For the next problem, we're going to take our differentiation, we're going to kick it up a notch because we're going to find the relative extrema by hand. Remember relative extrema from Calc 1? So let's see if we remember how to do it. To find relative extrema, we are looking for the local mins and max, the relative mins and maxes. So we would want to first find the derivative. I mean, that'd just be a starting point. So we need to find f prime of x. So that's step one. So we're going to find f prime of x. Actually, I'll just put that there. Okay, so f prime of x would be, well, this one's going to need product rule right there because that's multiplication. So it would be the derivative of x is 1, so 1 times cosh of x minus 1 plus, now leave the x alone, the derivative of cosh is sinh. There's technically chain rule involved, but the derivative of x minus 1 is 1, so it's not really it's trivial. Let's put it that way. All right, so the derivative of sinh is cosh. And again, some lovely things disappear for us. And so we're left with x sinh x minus 1. That's the derivative. Okay, step 2, find the critical values. So the first order critical values. First order critical values are when your first derivative is equal to 0. So we will take x sinh of x minus 1 and we will set it equal to 0. Okay, so x sinh of x minus 1 is equal to 0. So that means either x is 0 or sinh of x minus 1 is equal to 0. Well, that's easy. I mean, we have one critical value right there. But sinh of x minus 1, there's two ways we can do that. We can either use the definition of sinh, which we have. It's right here. Right? So we could take e to the x minus 1 minus e to the negative x minus 1 divided by 2 and go from there. Right? So that's one way we can go. So let me just kind of give us two methods. Right? So method number 1. Actually, I'm going to pick a different color here. And it's up to you which one of these you want to do. For your notes, of course, you want to write them both because there might be a case where one of them is more useful than the other. All right, so method number 1, you'd set e to the x minus 1 minus e to the negative x minus 1 divided by 2 equals 0. Well, I'm going to multiply both sides by 2, right? Really, the division by 2 is irrelevant. And up here, I'm going to distribute that negative x minus 1 and write it as 1 minus x. So this is e to the x minus 1 minus e to the 1 minus x equals 0. But remember that e to the x minus 1 is e to the x, well, I'm just going to do it. There's no point in writing it as a note outside. Sorry. I'm just going to write it. This is e to the x over e to the 1 minus e to the 1 over e to the x. So then I would multiply everything by my common denominator, e to the 1 times e to the x, which would get me e to the, over here the e to the 1s would cancel, be e to the x times e to the x, which is e to the 2x, minus, over here the e to the x's cancel, and I'm left with e to the 1 times e to the 1, which is e to the 2. So that means that e to the 2x is equal to e to the 2, which means 2x is equal to 2, which means x is equal to 1. So method number 1 uses algebra. And the definition. All right, method number 2, which I actually like a little bit better. I think it's a little sneakier, a little craftier. So method number 2, I'm going to pick a different color. So you'll notice that the sinh of x minus 1 is equal to 0. So that means that the arc sinh of 0 is equal to x minus 1, right? You take the arc sinh of both sides. So wait, we have a formula for the arcsinch. Arcsinch is this formula right here. So then we can use the formula for arcsinch, which is a little bit easier of a formula to work with, especially if with zeros involved, and say it's the natural log of 0 plus the square root of 0 squared plus 1 is equal to x minus 1, which means the natural log of 1, because this is 0 and that's 1. So that's the natural log of 1, which is 0, which means x is 1. Easier, huh? Yes, much easier. So either method, pick your poison, right? Either one of these will work. But one way or another, you're going to get 1 and you're going to get 0. Those are your critical values. Now at this point, we have to test them. So step 3, we need to test. Now, when you want to test whether or not something's a relative min or max, you actually have two options. You have the first derivative test and the second derivative test. Right? Those are the two big ones. And the question is, which one is the one you want to use? Well, if your second derivative is pretty easy to find, you're probably better off with the second derivative test, because the first derivative test requires you to make a table. So let me remind you. So we've already found f prime, we did the critical value stuff, but you'd have to build this whole table with intervals, right? From negative infinity to 0, and from 0 to 1, and from 1 to infinity, and then to make a test value, and then plug it in, and blah, 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 blah. Right, so it's pretty involved, and then does it switch from positive to negative, etc. So if you can find your second derivative easily, which we can, then I would say use this one, right? Because we've already done the first 3 parts, right? Then all we'll have to do is find the second derivative. Well, we didn't find the second derivative, but we're about to. So if we find the second derivative, then just substitute those critical values, 0 and 1, into that second derivative. Bing, bang, boom, we're done. So it's up to you. You have to use either the first or second derivative tests. I would recommend the second one if you can do it, as long as f double prime is pretty easy to find. So for our purposes, we're going to use the second one. Let's find f double prime. Remember that f prime is x sinh x minus 1. So f double prime would be, 1 times sinh of x minus 1 minus, or plus, it's product rule. And then leave the x alone, and derivative sinh is cosh. Right? I'm just doing a simple product rule on this. Derivative of x is 1, leave the sinh alone, then leave the x alone, derivative of sinh is cosh. Right there. Okay, so then let's find f double prime of our 2 critical values, and we'll be done. It'll be easy. See what I mean? So if you can find the second derivative easily, I like the second derivative test. Because it takes up less space, it's just simpler and easier, more straightforward. So we had 2 critical values, 2. Remember that we had the 0, that was the easy one. And then 1, you can find either one of these 2 ways. And again, for a problem you're actually going to do, you wouldn't do it both ways. In your notes, you do it both ways because you want to learn both methods, but in reality, you never do that. And then I want f double prime of 0 and f double prime of 1. I'm just going to go type this into Desmos, right? I'm not going to go figure that stuff out by hand. I'm not crazy. All right, so let's find this. There it is. Okay, so I have f of x right here. Look at this. F prime of x. I can have f double prime of x, right? I don't even need to know what they are, right? It's irrelevant. But I can find f double prime of 0. It's negative. F double prime of 1 is 1. It's positive. There we go. So I can find out what these are. I'm going to write them down really quickly. So this is negative 1.175, and this was 1. And the points are not really, the numbers are not important. What's important is this is negative, which means it was concave down, which means that we had a local max. And I realize that the graph shows this to you, but of course you're actually showing all the work to prove this. And this was a local min because this was concave up. Concave up means it's smiley face up, so it's a local min. And you can see it right here. There's x equals 0, which is a local max, right there at that peak. And down here, at x equals 1, it's a local min. So you can use the graph to back yourself up, but if you're told to do it by hand, you actually have to show all of this work. Well, you don't have to show both of these, pick one. But other than that, you have to show everything. But it should back you up. I mean, if we go to that Desmos graph, I should be able to click on both of those maxes and mins and find it out. Wonderful. Okay, so that's that. So therefore, right, I'm getting these from Desmos. That's what Desmos is there for. All right, and so they want the relative extrema. So now it's a little bit vague sometime in books what this means. So the relative extrema are points. Which are x, f of x, the original function, right? Not the f prime or f double prime, those are different things. So I would take my x values and I'd put them in. So to be 0 something and 1 something. And I could see them on the graph, right? So that you could look at them on Desmos. It was 0, 1.175, and 1, 1. Now, if you want, these are decimal approximations from Desmos. This one really is 0, and then it's e squared minus 1 over 2e, if you want to go back and use the definition. If you want to go substitute 0 back into this original and then use the definition of what that was. So if you're more than welcome to. So this one was a local max, and this one was a local min. Now, they don't always ask for the points. If they don't ask for the points, if all they ask is for the x values, then you're done here. But if they ask for the actual points, then you have to go one step further. Oh, and I should, of course, circle these because these are my actual answers. Ooh, my highlighter's dying. There we go.